Hello, and welcome to this introductory course for Amazon Web Services. The purpose of this course is to provide a high-level introduction to Amazon Web Services using oversimplification of concepts for the purpose of providing a frame of reference for you to move forward. What I mean by this is that this course is not going to teach you specifically how to use any specific AWS services, and it is not going to get into any technical definitions or explanations. What we're going to do here is, again, just to provide a high-level introduction, and I'm going to do that by really oversimplifying a lot of the concepts that we're going to talk about, just so that you can have a frame of reference to move on with. And now, moving on, whether that is to AWS certification courses or on to other cloud or DevOps type courses, or if you don't work in the IT field, maybe you're on the business side and you just kind of want to get a sense of what AWS is or what cloud is in general, this is a great course to start with. So first, let's talk about the cloud. Now, many of you are probably somewhat familiar with these icons, right? You see them a lot these days. Maybe you see them on your phone, maybe you see them on your desktop, and you hear terms like iCloud or Dropbox, or you hear sales pitches, which is something like store your files in the cloud. But then that really begs the question, right? What is the cloud? I talk to a lot of different people, and there seems to be a lot of confusion about what exactly the cloud is. Some people think that if they upload their pictures, their files to the cloud, that it's literally just kind of floating around out there in cyberspace. For the purposes of this course, and again, this is an extremely oversimplification of this concept, and I'm going to repeat that a lot because I just want that point to be extremely clear. But when you think about the cloud, right, I want you to think about it really as just a computer, just like a computer that you have on your desktop or your phone. It's just a computer that's somewhere else, right? And I know that may seem kind of odd or, again, an extremely oversimplification, but if you don't know what the cloud is or have no real conceptual understanding of what it is, just think about it in that terms first, okay? It's a computer that is somewhere else that you are in some way utilizing, whether you're utilizing its storage or its processing power, you're utilizing that computer that is somewhere else in some fashion, obviously using an internet connection. Now, in reality, it's not just one single computer, it's more of something like this, a data center, which you may have seen pictures of in the past, where there's just rows and rows and rows of server computers that you are utilizing. So when you think of companies like iCloud, Dropbox, or Amazon Web Services, your files or your pictures, your documents, whatever you're storing are not just going up into the cloud, into this magical mystery box. Your files are actually being stored on a server computer, which is in one of these racks, as they're called, in one of these data centers, which now there are many of all around the world. So Amazon Web Services, or AWS, is a cloud services provider, and that is also known as Infrastructure as a Service, or IaaS. Commonly, people refer to cloud service providers, they think about storage, computing power, databases, but something like Amazon Web Services offers a lot more in terms of networking, analytics, developer tools, virtualization, security. Now, you're not going to have to know or understand what all of these terms are, but I just want you to get the picture that whereas you may have used something like iCloud or Dropbox in the past to store pictures, videos, some documents that you may have, that is only a very small subset of what cloud computing is. And the list that I have in front of you here, while certainly not all-encompassing, is a much broader list of things that cloud service providers provide. So why do individuals and companies use AWS? What are the benefits? How is the cloud different from what has been used in the past? So let's discuss that now. For some common personal uses of cloud services, so think about iCloud, Dropbox, or AWS to a certain extent, here you are on your home computer. Now, you may use iCloud or Dropbox to store videos, pictures, or some personal files that you may have. And what cloud allows you to do specifically for an individual is backups and sharing. So you use iCloud or Dropbox as an additional backup for the pictures that you have from vacations or some documents that you have or music or videos that you want to save. And on your home computer, on your home hard drive, there's always the risk that your hard drive will fail. So you use the cloud for backup, so there's always another copy. The cloud is also great for sharing. And I don't necessarily mean that in terms of sharing your files or your pictures with other people, but sharing it across devices. So you can access the same files on your mobile device, or if you're at work, from your work computer. And it just means that your files will be available anywhere that you go, and you can access them from any different type of device. So with that, I want to introduce two pieces of cloud terminology. Number one, which we'll call high availability, and number two, which is fault tolerant. Now, when I talk about high availability, again, this is an oversimplification of what high availability is, but just think of it like this. If you put a file up into the cloud, you can access it from any type of device or any type of computer as long as it has an internet connection. So that makes that file highly available. You can access it from anywhere. Also, when you think about fault tolerant, there's several different ways that you can use the term fault tolerant. Here, I just want you to think about that if you have a file only on your home computer and your home hard drive fails, then it's gone. So the system that was in place did not account for that fault being the fault of your hard drive. But if the file is up in the cloud and it's backed up on multiple services, then that file can become corrupt, or the cloud server that it is currently stored on can fail, and there will always be another copy for you to access. So if there's a fault in the system, you will still always have the ability to retrieve that file. So the terms high availability and fault tolerant really go hand in hand, meaning that your files are always available across multiple devices, and if there's faults in the system, wherever that may take place, you will still be able to access your files because there's backups and other ways to access it. So again, high availability and fault tolerant are two terms that we need to know as we start to learn about AWS and cloud computing in general. So now let's talk about some common enterprise uses of cloud service. So here's an example of a company. We're just calling this software company. And if this company is not using cloud services, that means that they're currently using on-premise servers to run their company, meaning that they have server computers which are storing their data, handling their code, or when customers use their software, they're accessing the software on the company's servers. Now, in this example, let's say that it is 2016 and this company currently has about 1,000 users, which takes 3 servers to power the software for those 1,000 users. So now let's say we're looking forward into 2017, and this company is estimating that in 2017, they're going to have growth and they're going to have 5,000 users. Now, if they're going to have 5,000 users, the 3 servers that they originally had would not be enough. So they're going to add an additional 3 servers to handle the load of having more users. But in order to add 3 additional servers to their on-premise data center, they're going to have to, one, have the size and the space to put these servers into their data center. They're also then going to have to research what type of servers they need. They're going to have to buy them. That's going to cost generally a significant amount of money. They're going to have to wait for delivery, which can be anywhere between a week to several weeks for servers. They're then going to have to set them up, test them, install operating systems, software, get them all up and running. That can take a lot of time. So let's assume that their estimates were right, and in 2017, they increased their user base to about 5,000 users. And the 6 servers are currently working for them in the user base that they have. Now let's look forward to 2018, and let's say that they're now expecting 20,000 users, or estimating 20,000 users in 2018 as their company and user base is growing. So now they would have to add an additional 12 servers. And again, now they must make sure that they have the space in their data center. They would also now need to spend the money for these servers, again, go through the process of ordering, waiting for them to come, installation. But one of the major problems here is that they may have now spent tens of thousands of dollars on these high-end servers, But what if in 2018 they were wrong and they didn't get 20,000 users, but they only topped out at 7,000 users? So now a whole segment of the servers that they just purchased for 2018 aren't being used. So it was a tremendous waste of resources, a tremendous waste of money for something that is not being used. And now they would have to sell the servers or just let them sit there until the user base were to increase. But for a company, specifically a growing company, spending the tens of thousands of dollars on these servers may have been a big investment. And if they didn't get the user base to back that up, it could be a major loss for the company. This is a problem with on-premise data centers that something like cloud services seeks to solve. So now let's take a look at the same scenario, but if the company is using a cloud service provider such as AWS. So in 2016, again, this company currently has 1,000 users. And let's say for this example that they have 2 servers that they currently have provisioned and are using in the cloud. As the company grows, at this time, I'm not even going to put a timetable on it because the timetable doesn't matter anymore because the company no longer has to project or estimate future growth. Naturally, as the user base increases, say from 1,000 to 4,000, cloud service providers, and again, this is an extreme oversimplification of this concept, but cloud service providers, as user base grows, can automatically and instantly add additional servers. So the company didn't have to estimate growth, make sure that they have room on their on-premise data center, spend the time and research to figure out what kind of servers they need to buy, order them, wait a few weeks for delivery, install them, install operating systems, test them, load their software onto it. Literally within minutes, using a cloud service provider like AWS, they could immediately have 2 new servers up and running with their software installed. And that can be done at any time. So a process that used to take several weeks can now be done in a matter of minutes using a cloud service provider like AWS. So now let's continue this and look at an example where maybe the user base was at 4,000, but now dropped to 3,000. Now, if you notice here, as it dropped, one of the servers is now gone. Because what happened here is that when you use cloud service providers, especially when you're using servers, you're only using them when you need them. So the second the user base dropped from 4,000 to 3,000, the cloud service provider simply just decommissioned that server, and this particular company is no longer being charged for it. So unlike in the on-premise example, when they had to buy physical hardware, install it in their office, and then if it wasn't used, they still were stuck paying for that hardware. Using a cloud service provider, you're only leasing hardware on an on-demand basis, meaning that as your user base grows, you can add more, and as it shrinks, you can pare those down and no longer pay for them. So that's going to introduce 2 more pieces of cloud terminology called scalability and elasticity. So this is, again, 2 other major reasons, especially why enterprise companies use cloud services. So when I talk about scalability, what I mean is that as user base grows, you have the ability to quickly and easily add more servers. So you can scale up extremely easily. Now, elasticity means that you can grow, but you can also shrink. So as you go from 1,000 users to 4,000, you can grow, but as you drop down to 3,000 users, then you can pull back in, you can shrink that down. So think about elasticity, right? A rubber band. So that's what I want you to think about when you think about scalability and elasticity, the ability to quickly and easily grow and shrink on demand as needed. Okay, so let's do a quick recap. Again, we talked about the cloud and what the cloud is. And again, what I want you to think about when you think about the cloud is just a computer somewhere else that you are using in some fashion. And AWS is a cloud services provider. We then have our 4 cloud terms that I introduced during this video, which are high availability. When you think of high availability, just think about your files are available all the time and from any device that you want. With fault tolerant, think about that if something were to go wrong, a hard drive were to crash, a computer were to go down, that there's backup, that no matter what goes wrong, you'll still be able to access your files and your files will never be deleted. For scalability and elasticity, again, just think about the ability to quickly grow and shrink on demand based on your needs. So the 4 terms listed here are the major reasons and advantages why both personal users and enterprise users love cloud services. So what's next? What's going to follow in the next few videos of this course? And this is what's going to follow. Now, if you were to right now Google AWS architecture, you're going to see a ton of diagrams that look like this, albeit probably a lot more complicated than this. But this right here is a very simple diagram of AWS architecture, and we're going to walk through some of these services in the next few videos, again, on a very high level. And I'm going to oversimplify a lot of these, but it's going to give you a great frame of reference to understand what these services and what these concepts are going forward. So we're going to take a look at VPC, at Amazon S3, Amazon EC2, and Amazon RDS. And we're going to talk about how these all work, and we're going to relate these concepts by talking about Facebook and Netflix. Now, Facebook is going to be used as an analogy to describe VPCs, and then we're actually going to talk about Netflix, because Netflix is actually the #1 Amazon Web Services user, and we're going to talk about how Netflix uses these services so that you can understand the basics of why a major company like Netflix uses these services, and hopefully this will allow for a very understandable way to understand these concepts. Okay, so that will conclude this video. I look forward to seeing all of you in the rest of this course. Thank you for watching. You may now move on. Hello and welcome back. In this video, we're going to continue our introduction to AWS, this time talking specifically about EC2. Again, I want to reiterate that here we are providing a high-level introduction to Amazon Web Services using oversimplification of concepts for the purpose of providing a frame of reference for you to move forward. So if you have not watched any of the previous videos, I just want to make this point very clear in that the concepts that I'm sharing and the way that I'm talking about these AWS resources is in a very oversimplified fashion. And this is only to provide a frame of reference and a general understanding of these concepts so that as you take more advanced courses, it will be easier for you to absorb and understand the more technical aspects related to these items. So, as promised in the previous video, here we're going to dive into Netflix and understand how Netflix uses AWS resources such as EC2, RDS, and Amazon S3 to power their website. Now, I'm using Netflix because it is probably one of the most well-known websites in the world, and I assume that most of you either have a Netflix account, use Netflix on a regular basis, or at least somewhat aware of what Netflix is. But if you aren't, just understand that Netflix is probably right now the world's #1 provider of video content, streaming video content, and they are AWS's #1 customer or user of cloud resources. Now, specifically how Netflix utilizes and uses AWS, again, this is a drastic oversimplification of how Netflix actually uses AWS. They use a lot more than just these 3 services. So as mentioned earlier, in this particular video, we're going to talk specifically about Amazon EC2. So right now, let's just get rid of those other 2 and focus specifically on Amazon EC2 and what EC2 is. So Amazon EC2 is short for Elastic Cloud Compute, but don't worry about remembering that right now. All you need to know is conceptually what EC2 is and what it does. So when you talk about EC2, what I want you to do is just think about a basic computer. That's basically what EC2 is. It's the virtual equivalent of the computer that is currently sitting in front of you. Again, that is a drastic oversimplification, but in terms of the concept, that's essentially what it is. So what does a basic computer have, right? It has a CPU for processing power, an operating system, in AWS's case, either Linux or Windows. It has a hard drive or local storage, a network card, how it can access the internet. It has a firewall for security, and RAM to access and run programs. However, in terms of AWS, I don't want you to actually think about a base computer. I want you to think about a server computer, because generally AWS is used by enterprise companies, And generally, they're using these computers or this compute power as servers. So now I want to introduce another piece of cloud terminology called instance. So a lot of times in AWS, an EC2 server will be referred to as an EC2 instance. So you will hear terms like provision an EC2 instance or spin up an EC2 instance. So if you hear instance, just think server. When you hear instance or server, just think EC2. And if that is still a little unclear to you, you can always just think about EC2 as a basic computer, right? It just has these components, and then you can do with it whatever you would like. So now, how does Netflix specifically use EC2? So when you go to www.netflix.com, you come to their homepage, and you would see something that looks exactly like this. So in essence, what the Amazon EC2 instance is doing is it's acting as a server or a web hosting server. So when you go to www.netflix.com as a user, so you're here, you have an internet connection, you go to www.netflix.com, you are in essence connecting to an Amazon EC2 instance, which is currently serving as a web hosting server, and that EC2 instance contains all of the files and the code to give you this page. So that is one of the main features and functions of an Amazon EC2 instance in the world of Netflix, or in most of the internet as a whole, is it acts as a web hosting server. It contains all of the files and code needed to display a web page to any particular user that visits their site. Okay, so again, let's quickly recap. I want you to think of EC2 as a virtual computer that you can use for whatever you like. One of the common uses of that is as a web hosting server. Also, we introduced the cloud term instance, which is another way of referring to an EC2 server. So what's next? Next, we're going to talk about what happens when you actually go to sign in and put your credentials into netflix.com. So with that, we will conclude this video. Thank you for watching. You may now move on. Hello, and welcome back to our continuation of Introduction to AWS, and this time we are going to talk about RDS. Again, I'm going to reiterate that the purpose of this course and these particular videos are to provide a high-level introduction to Amazon Web Services using oversimplification of concepts for the purpose of providing a frame of reference for you to move forward. I'm repeating this over and over again in each video, one, in case somebody is watching this video without watching other videos in this course, and just to really hammer home the fact that the way that I'm posing these concepts, terms, and resources, I'm doing so in an overly simplified fashion, just so that you can get an understanding of what these concepts, terms, and services are, so that later on when you dive into more advanced courses, you'll be more apt to absorb the technological aspects of those, since you will already have a conceptual understanding. So in the previous video, we talked about Amazon EC2 and its common uses, mainly being web hosting. So when you go to www.netflix.com, right, it is the EC2 instance that you're essentially connecting to, and it is serving up to you the homepage with the files and code to do so. So what we want to do now is talk about what happens when you actually go to sign into Netflix. You put in your credentials or you create an account. Something has to be done with your own personal information. So this is where something like Amazon RDS comes into play. Now, Amazon RDS is a database platform provided by Amazon Web Services, and one of the most common uses of database programs is to store customer account info. So when you go to netflix.com and you go to sign in or you create an account, it needs to save, your name, your email address, your credit card information somewhere. So when you are on netflix.com, which is being hosted on the Amazon EC2 instance, and you input your information, it then either goes and stores it in a database, or if you're signing in, it will cross-check that information with the information in the database and then serve that information back up to the EC2 server, which then gets served back to you and to your computer. Now, what about once you've signed in? There's the entire list or the entire catalog of all of the shows and all of the episodes that Netflix has to offer. The catalog, or what we can talk about as an inventory catalog, is also another common use of RDS or database programs. So once you sign in, it is then going to populate Netflix.com with a list of the TV shows and episodes that are currently in the catalog. So when you think about Amazon RDS, always think about with something like Netflix, your account information, or a full list of the shows and the episodes. That is all being stored in a database program. And that information will be requested and then served back up by the EC2 server that is hosting the website and running the code. So now that we have an understanding of Amazon EC2 and Amazon RDS, we're going to walk through a couple of scenarios here. So I'm kind of going to rearrange this diagram a bit. I just kind of shrunk it down. I mean, everything is still there. I just kind of shrunk it all down into a smaller section. So I want to run through and again touch on the cloud terminology of scalability and elasticity, because these are two terms that you're going to hear a lot going forward, and it's important to really understand these concepts and to be able to know what they are, because of the fact that these two terms are one of the main benefits of cloud computing and using Amazon Web Services. So let's walk through this scenario where, let's say right now, this user here represents, thousands of users. And let's say it is 7 p.m. in any particular time zone. So we all know that Netflix gets its most users in the evening in any particular time zone. So let's just use the United States East Coast as an example. If it's 7 p.m. at night, people are getting home from work, they're having dinner. Then by about 8 o'clock, they start to settle in and they want to watch some TV. So by the time 8 o'clock hits, there's now more users that are using Netflix. Then by maybe 8:30, there's more users. And by 9 o'clock, there's even more users. And by 10 o'clock, there's 5 times the users that were currently accessing Netflix at 7 p.m. Now, under the on-premise model, so if you remember back a few videos to the first introduction video for this course, we talked about the difference between on-premise and cloud in terms of scalability and elasticity. And that if more users are trying to use your system or your software, then you generally will need more servers. So if in this example here, if this server was just on Netflix's on-premise data center and they didn't have the ability to add more servers on demand, meaning that if user base were to grow, they would have to order them, have them delivered, install them, which could take weeks, right? Something like this would happen. All of the new users that were coming on at 8 o'clock, 9 o'clock, 10 o'clock would all be hitting this one server. Now, the server can only handle a certain amount of traffic. So if there's too many users trying to hit just one server, that server is going to crash. And when that server crashes, then nobody can access Netflix. So if you've ever heard the term or heard somebody say, oh, hey, that website crashed, or there was too much traffic, or the traffic was too heavy, it crashed the server, this is specifically what happened. There were too many people trying to hit one server, the server overloaded, it crashed, and then nobody else can access it. So this would be an example of something that would happen if you had a quick increase of users on an on-premise network or an on-premise server. So clearly this example does not have scalability and does not have elasticity. So now let's reset this. And again, this time we're going to go through the same example, but this time this is an AWS example. So we're no longer using on-premise as an example. As users get added, the great thing about cloud, and again, this is a very oversimplification of this particular concept, but as users come on at 7:30, 8 o'clock, 9:30, AWS will automatically add another EC2 instance to handle those particular users. So then if by 9 o'clock, 10 o'clock, or 11 o'clock, users double or triple, it will constantly keep up by adding new instances inside the VPC that all can talk to the database, so all of the users can access an EC2 instance that isn't being overloaded, and all of those EC2 instances are talking to the database so that everybody can log in, access their account, and be served up the inventory catalog. So this would be a valid example of scalability. As users were coming online throughout the evening, we were able to scale up with more instances and handle the influx of traffic. Now, in terms of elasticity, what if, as we rolled into 11 o'clock, 12 o'clock, 1 a.m., users were to drop off? Now there is nobody using instances 4 and 5, and the great thing here is that Amazon Web Services, once those resources are no longer being used, can just remove them from your VPC and from your account, meaning that you are no longer paying for them. You are only paying for the use of those instances for the time that they were needed. So this would be a valid example of elasticity. Now, to this example, I also want to bring in the other two cloud terminology items that we discussed earlier, which were high availability and fault tolerant. So if you remember, I talked about high availability as being able to access your files or your information from anywhere and having it always be available, and fault tolerant meaning that if something in the system were to break, there would be a workaround or you would still be able to access the files or the information that you need. So in this particular example, we clearly are highly available, meaning that as users came on to use Netflix, new instances were provisioned, and so Netflix.com was always available, right? So there wasn't only one instance, and if that instance got overrun, then it would crash. Here, because of scalability and elasticity, Netflix.com is highly available to all the users that come to their site. Now, in terms of fault tolerance, let's look at it in this light. Let's say that currently EC2 instance number 3 right here were for whatever reason to crash. So if this were to happen, all of these users that were using this EC2 instance would no longer be able to access Netflix. One of the great things about cloud computing and AWS is that if that instance actually crashes for whatever reason, and it doesn't have to crash because of too many users, there could be many other reasons why it would crash, it can just redirect these users over to this instance, assuming that this instance can handle double the load, which in most cases it probably could. Now, AWS will automatically take that instance, decommission it, remove it, and then automatically launch a new instance in its place. And then once that instance is back up and running, simply move those users back to that instance. So that is a simple example of fault tolerant, meaning that when there was a fault in this instance right here, without skipping a beat, all it did was redirect these users to another EC2 instance. And again, it's all connected down to the same database, so it can get the same customer information, the same inventory catalog. It's all seamless and done automatically. And then once a new instance was provisioned again, which in AWS's case would only take a few minutes, the users are then redirected back to that instance, and we have a nice parity across the network. Again, a great example of fault tolerant. So when I ran through this entire example of users coming on and users coming off, or instances failing and then being reprovisioned, these are great examples of high availability, fault tolerant, scalability, and elasticity. And the example that I just posed is one of the primary reasons why a site like Netflix and many companies now turn to the cloud and services like AWS. Okay, so just to recap again, RDS is a AWS provisioned database service, and it is commonly used for things like storing customer account information and cataloging inventory. We also again talked about these 4 pieces of cloud terminology: high availability, think your files are always available, always accessible, websites are always accessible; fault tolerant, if something happens to crash or go wrong, it will fix itself; Scalability, the ability to, as users or demand increase, you can add more servers to cover that increase in demand. And elasticity being the ability, once that demand subsides or reduces, you can scale down or back quickly, thus saving you money and not having to lay out upfront money to buy hardware to install on your on-premise data center. Okay, so up next, we're going to talk about where we store and keep all of the physical files, especially all of these thousands upon thousands or tens of thousands video files that Netflix has to keep and manage in order to serve up this content to you. So with that, we will conclude this video. Thank you for watching. You may now move on. Hello and welcome back. In this video, we are going to continue our introduction to AWS, this time focusing on S3. However, first, as usual, I do need to give the disclaimer that this course, and specifically these sets of videos, are to provide a high-level introduction to Amazon Web Services using oversimplification of concepts for the purpose of providing a frame of reference for you to move forward. So, when we left off at the end of last video, we had discussed how Netflix uses Amazon EC2 as well as Amazon RDS and how those services are used and how they're reflected when a user actually goes to www.netflix.com. Now we're going to dive into where Netflix actually stores the thousands upon thousands, if not tens of thousands, if not even more, of actual video files that power their content. So episode 1, episode 2, episode 3, there have to be those video files, multiple versions of them stored somewhere. And this is where S3 comes into play. So Amazon S3 is the storage platform of AWS. And specifically, what Amazon S3 is it's basically just a large unlimited storage bucket. Now, when I say unlimited, obviously there's a limit in there somewhere, but that limit is so unbelievably high right now that no individual user or company even comes close to reaching the theoretical limit of storage capacity currently allowed in S3. So S3 is a perfect place for any documents, movies, music, applications, pictures, anything that you have that you want to store, you can drop into S3 and it is going to be there for as long as you'd like, and it is going to be multiple redundancies and backups of the files that you put there. So again, you're always going to have high availability of any files that you decide to store in S3. Now also think about a service like Dropbox that you may have heard about or may currently be using. Dropbox actually is just a nice user interface that is backed up with S3 storage. So when you upload a file to Dropbox, if you use Dropbox, you're actually just putting your file into an Amazon S3 bucket. So down here, I've now marked several common uses of Amazon S3, and one is it's just a mass storage container. And it is also great for long-term storage. Now, if you remember Amazon EC2, I told you to think about that just kind of like a regular computer. And as a part of that, it has a hard drive or a local storage. Now, the hard drive or the local storage on Amazon EC2 isn't permanent in the sense that anything that you want to store long term, you don't want to store on the hard drive of your EC2 instance, because if you remember before in the previous video when we talked about RDS, I gave the example of scaling up and scaling down and adding EC2 servers, removing EC2 servers. And so you don't want to have things that you want to keep forever on EC2 local storage, because as you add or remove instances, then you could potentially lose that information or lose that data. Now, when you get into later courses about Amazon Web Services, you will find that there are different ways to work around those restrictions when using Amazon EC2. But as a total fail-safe, Amazon S3 is the perfect place for anything that you want to keep for a long time, and it has a load of redundancies, and it's great because it's basically unlimited storage. So Amazon S3 is where Netflix stores the petabytes upon petabytes of video files that they have to store. So just to quickly recap, Amazon S3 is a massive storage bucket. It's really just as simple as that. Obviously, there's a lot more to it when you actually get into the technical details of it. But for now, all I want you to realize, or what I want you to remember, is that Amazon S3 is a massive storage bucket. Next, what we're going to do is actually go into EC2 Part 2, and we're going to talk about what actually happens when you click play on Netflix to start streaming a video. But for now, that will conclude this video. Thank you for watching. You may now move on. Hello and welcome back. And in this video, we're going to continue our introduction to AWS, this time circling back around to EC2 for what I'm calling EC2 Part 2. Again, and I'm sorry I keep having to reiterate this, but I just want to make extra clear for anybody that is viewing this video without viewing previous videos that what I'm doing here is providing a high-level introduction to Amazon Web Services using oversimplification of concepts for the purpose of providing a frame of reference. So everything that I'm talking about here is going to be very oversimplified, avoiding any deep technical speak or terminology in order just to convey the general concepts that we're talking about. So when we left off last time, we were talking about Netflix and how Netflix utilizes Amazon EC2, Amazon RDS, and Amazon S3. And we talked about how Amazon uses EC2 for web hosting. They use RDS or other AWS database services for things like customer account information and inventory catalog, and how they would also use something like Amazon S3 as the mass storage service for all of the video files for all of the movies and TV shows that they would like to stream to their customers. So now I want to talk about what actually happens when you hit play on one of the movies or TV episodes on Netflix. And so generally what happens here is this is again where EC2 comes back into play. Now, if you remember, I described EC2 as a computer that has a processor and it has processing power. So that is generally one of the main things that Amazon EC2 is used for, is anything that requires computer processing, right? As opposed to something like Amazon E3, which is just for storage, or a database, which is for organizing information. Amazon EC2 is for things that need compute power. So when somebody hits play on Netflix, what occurs is that the Netflix code has to go to S3, find that particular television show or movie, pull that file, and then on the Amazon EC2 instance, they're going to either encode or transcode that movie or that piece of data so that it is ready to be sent across the internet down to the user so it can be viewed on their device. So encoding or transcoding video, again, is very processor intensive, and so it requires something like an EC2 server in order to accomplish that task. So again, just to recap, as this is a very quick video, Amazon EC2 is good for any type of processing activity. So whether that's web hosting, whether it's an encoding, transcoding, whether it's something that is graphically intensive, whether it's something where there's a lot of mathematical equations going on, anything that needs general basic processing, EC2 is the solution that you're looking for. So coming up next, we're actually going to leave the VPC AWS services sphere, and we're going to take a look more in a large scale of AWS, and especially take a look at this map and start to talk about their global infrastructure, right? How are they set up from the 35,000 foot view? And then we'll kind of take that view and drill back down to the VPC to kind of bring everything around full circle. And I just want to make a quick note that this image is provided specifically by Amazon with the image source link at the bottom. And with that, we will conclude this video. Thank you for watching. You may now move on. Hello and welcome back. In this video, we're going to continue our introduction to AWS, this time focusing on its global infrastructure, meaning we're going to talk about how physically AWS is set up and deployed around the globe. As per usual, here's my disclaimer about this course and these videos being a high-level introduction using oversimplification of concepts to create a frame of reference. So again, everything that I'm sharing here is being deliberately oversimplified only to convey a general understanding and knowledge of the topics that we are currently talking about. So at the end of the previous video, I gave a sneak peek of this map. And what this map is it is a map which shows the locations of all of the AWS regions. So what are AWS regions? So each region is a geographical area that is a collection of AWS availability zones and data centers. So just to give you an idea of why there's all of these regions spread out across the world is specifically this. If somebody is in Tokyo and they're using AWS and they want to provision and use an EC2 instance, they want to be able to launch that EC2 instance on physical hardware that is in a data center in Tokyo, because they want that physical hardware to be close so there's a lot less latency while transmitting data. Whereas if they had to provision and use an EC2 instance, say that was in North Virginia, any data that they were to send back and forth would have to travel halfway around the world and back, thus taking a lot more time and having a lot more transmission latency. So AWS, to be fair to all of their customers around the world and to provide the absolute best performance, has put regions and data centers and physical hardware all around the globe. And there's currently 11 active consumer-based regions, with one government-based region being the AWS GovCloud. And then there is also four new regions which are currently under development at the time of this recording, which is in September of 2016. So now what we're going to do is we're going to zoom in on one of these regions to see what's going on. So let's hypothetically say we are zooming in here on the North Virginia region. So once we zoom into an AWS region, we see that it is made up of availability zones. Now, each region may have a different number of availability zones, but for this example, let's say that this particular region has 3 availability zones. Now, what is an availability zone? Availability zone is actually a geographical physical location that holds an AWS data center. So now we've zoomed into an availability zone, and there's where we see the physical hardware, the physical data center where all of the AWS resources and any data or information that you put on AWS is located. So now we zoom back out again, and we'll go through this again. Here are all the regions across the globe that AWS has set up. Each region has a set of availability zones. Now, each one of these availability zones contains a data center, and each one of these availability zones is geographically separated from the other. So if this is the North Virginia region, there is an availability zone with a data center somewhere in North Virginia, and then some miles away, whether it's 20 miles, 50 miles, 100 miles, somewhere else in that region of the country, there is another availability zone. And in most cases, there's also a third and sometimes a fourth availability zone. Now, why do they have all these various availability zones within a particular AWS region? And that again goes back to high availability and fault tolerance, in that let's say that there was a natural disaster somewhere in North Virginia. There was a major earthquake or power outage or something that actually knocked out one of these data centers. Within a region, there is redundancy across these availability zones. So if availability zone 1 were to fail or go down, most, if not all, of your files have already been backed up in availability zone 2 and availability zone 3 within this particular region. So as long as it doesn't knock out the entire region, then you still should be able to access AWS resources and any files or information that you have uploaded and use in AWS. So again, when we zoom into one of these availability zones, we see that the availability zone is where the physical hardware that makes up the data center is located. Then it is inside of these servers, inside of these racks, inside of these computers here, where this is located, right? Where your VPC is located, where when you actually launch an EC2 instance, or you place a file inside of an Amazon S3 bucket, Well, back out now. This is all taking place within a data center, which is located within one particular availability zone, which is located within a region that AWS has set up. So again, to zoom back in, we have our regions. Within our regions, we have availability zones, and there are multiple availability zones for redundancy. And then inside each availability zone are data centers, the physical hardware, and then it is on those physical pieces of hardware that you create and provision your AWS resources or utilize something like an S3 bucket. So when you create an AWS account and you go to create a bucket or to launch an Amazon EC2 instance, you're always choosing what region and what availability zone you want those things to take place in. So I hope that explanation gives you a good overarching understanding of the general concepts of how AWS is set up globally and how their infrastructure is viewed from a very high level and then paring it down to a very local level. And with that, we will conclude this video. Thank you for watching. You may now move on. Well, let me just say congratulations on completing the AWS Concepts course brought to you by Linux Academy. Now that you've completed this course, you might be saying to yourself, well, what should I do next? I've just learned some key concepts about AWS and cloud computing, and I want to learn more. Well, we have you covered here at Linux Academy, as we now have 2 additional courses that we offer here on Udemy that I want to talk about now. So let's take a look at this AWS course roadmap that I've put together for you that is going to take you from this concepts course, which you have just completed, all the way through becoming an AWS certified solutions architect. So as you can see here, I have a check mark right next to AWS Concepts because you have just completed that course. And just to kind of recap, this course was for the absolute beginner. So it was for somebody that had no idea what AWS or cloud computing was. So again, congratulations on completing this course. Now, if you really want to start to dive in and dig your teeth into AWS and start to actually use AWS and build some web applications in AWS, then what you should do is move on to our AWS Essentials course. This is also a beginner level course, and in it what we're going to do is conceptually teach you about AWS, some specific services, and give you some hands-on experience in using those particular services. So unlike the concepts course where we just talked about AWS and what it is, in AWS Essentials we're actually going to teach you how to create an account, use various services, and learn a lot of the concepts and theories behind AWS and how to build highly available fault-tolerant architecture in AWS. Now, one of the great main features of the AWS Essentials course is Project Omega, and that is a linear, project-based, interactive, and visual learning guide. And I'm going to show you exactly what I mean by that in a second. Once you finish the AWS Essentials course, then you should move on to the AWS Certified Solutions Architect Associate course. Now that is an intermediate level course and should be only taken once you've completed both AWS Concepts and AWS Essentials. And this course will provide in-depth AWS learning to prepare you for the AWS CSA Associate Level exam. And the main feature of that course is the Orion Papers, which is a nonlinear, service-based, interactive, and visual learning guide. So right now you're probably saying to yourself, well, what is Project Omega and what is the Orion Papers? Well, let me show you. So this is Project Omega, and this is a visual, interactive tool that allows you to learn AWS in a much more visual way than just standard PowerPoints. And what do I mean by it's interactive? Well, you can click on almost everything. So during the AWS Essentials course, we're going to be building out this entire architecture piece by piece, and you're going to be learning about each one of these services and each one of these features throughout each lesson. So what we can do here is, as we build the diagram, we're going to start with nothing, and then we're going to talk about account basics. Then we're going to talk about identity and access management, then the VPC, then S3, then EC2, so on and so forth. And we're going to build and learn about each one of these pieces of the architecture together as we move through the entire course. Now, what we'll be able to do is then dive down into each one of these services and then have specific lessons on things like what is IAM, setting it up, users and policies, groups and policies, and then within each of these lessons, we'll move through multiple tabs and diagrams to explain how all of these features work. So we've structured the entire course around building this architecture inside of the AWS console, while also having this tool as a visual supplement to help you really understand what's going on as we're building this architecture and learning all of these various servers and features of AWS. So again, this is the tool, which is Project Omega, and this is for the AWS Essentials course provided to you by Linux Academy, which is offered for free here on Udemy. So what about the AWS Certified Solutions Architect Associate Level course? Well, for that, I had mentioned something called the Orion Papers. So the Orion Papers builds on the concept of Project Omega in terms of that it's an interactive visual guide, but it does have a slightly different format. So let's take a look at that. So this is the Orion Papers, and this is the brother or sister, whichever you prefer, to Project Omega. And what I've done here with the Orion Papers is instead of doing a linear section by section, lesson by lesson walkthrough in the form of a diagram, this is a completely non-linear format, meaning that we can use this to dive into all the various aspects, features, and layers of AWS to learn about them in a very visual way. So just to give you an example here, at the very high level, I've broken AWS into two different layers, an account and services layer and a physical and networking layer. So clicking on the physical and networking layer, what we can do is we can take a look at the highest level in terms of how customers or front-end users or AWS users and back-end users can connect to AWS in terms of what are the broadest areas that you can connect to of AWS, being regions or edge locations. Then we can drill down into AWS regions, drill down into availability zones. We can then click on this to learn about availability zones, or we can click on AWS regions here to actually get an understanding and definitions of what regions are. We can then dive into our VPC for the VPC networking sections, in which then we can learn how data is routed in and out of AWS from either a consumer standpoint or from an AWS user standpoint through things like Route 53 and how things like content delivery systems work or static web hosting. And we can also then drill down into the actual VPC itself, and then we can learn about all the various components and aspects of the VPC, not just from a basic VPC standpoint, but for highly available and fault-tolerant architecture, for Bastion hosts and NAT networking, and also for troubleshooting as well. But then within each of these components, we're going to learn how to build each one of them, and each one of these is clickable and will bring up specific points, not just definitions, but specific things that you need to know to not only pass the AWS Certified Solutions Architect exam, but also to be a great solutions architect in AWS in a practical way, because we don't want to just create a paper certified solutions architect in terms of what we want you to be. We want you to be able to pass the exam, but have a real deep understanding of what's going on in AWS. And everything that we do here is going to be side by side in our lesson videos where we're doing work in the actual AWS console. So that is the Orion Papers, and that is Project Omega, and those are two of the brand new interactive visual ways that we have forged our learning experience here at Linux Academy. Now, if you're wondering, how do I access either the AWS Essentials course or the AWS Certified Solutions Architect course, all you need to do is go to Udemy, and right up here under the search, you can type in AWS Essentials, then click on that. There, AWS Essentials. And right here under AWS Essentials, you will see from Linux Academy. What you want to do here is just click on this, and it is free, but you can click on this here and you can enroll in the course and get started. The approximate length of this course is about 6 hours with about 47 lectures for you to watch. So again, congratulations on completing the AWS Concepts course. And I really hope that throughout this course you gained a good fundamental understanding of what cloud computing is, as well as Amazon Web Services. And I hope that you come join us in AWS Essentials and the AWS Certified Solutions Architect courses provided for you here on Udemy by linuxacademy.com. And with that, you can conclude this lesson and this course. Thank you for watching.